Hello everyone, this is Udaditya from TechSpock, and we're here with another session covering the data engineering Q&A. So a little bit about myself, I have been working in data engineering domain for almost 9 years with various projects and involved in creating data pipelines for several clients. I also train candidates in this field to help them build an interview-ready profile with a comprehensive course covering all the necessary topics of data engineering. In today's session, we're going to talk about another key feature of Hive, which helps in query optimizations and performance enhancement, which is known as bucketing. So, what is bucketing and how it is different from the Hive partitioning? So, this is another useful big data related question that is being asked in most of the interviews. Okay, so just to understand why bucketing is introduced, even though this is like a secondary key component, secondary key feature of Hive, but still it's as useful as partitioning in some of the cases where partitioning cannot be achieved, or the optimized result is not as good, even with the partitioning. So bucketing is a technique. It's also known as the clustering, and you will understand when I do the create table statement for a bucketed table that why I am writing over here clustering instead of, as along with bucketing. So it's a technique to split the data into more manageable files. The value of the bucketing column will be hashed by a user defined number into buckets. So this hashing things, whatever is mentioned here, don't get panicked, because I will explain how this hashing works and what this hashing means actually. So I'll come to this later. But before, we need to understand why bucketing is something that we should consider, even though there is already one phenomena which is partitioning, right? So, creating a bucket on top of a partition table to further divide the table for better query performance is also a helpful tip. Not necessarily that only one of the two, that is either partitioning or bucketing, should be used in one table. We can also have a table which is already a partition, can be bucketed as well. So that's one plus point. Secondly, creating a bucket table on where you cannot choose the partition column due to too many distinct values on columns. So that's where also bucketing comes into play, when we cannot really choose a field for partitioning, due to like having low cardinality of that field value. So what does this low cardinality, or what does cardinality mean as a whole? So suppose if I have a column value which is not too repetitive, it has a lot of unique values. So if, for example, if I have a table on which the event date or a timestamp, if I consider for partitioning that table, in that case what will happen, that for each and every timestamp or even each and every day, there will be say two or three records. And if I consider a whole year of record, or say like 10 years of record, keeping partition for each and every single day doesn't really work. You can understand that we will have like thousands of partitions for a 10 year of record, even like 200, 300, hundreds of partitions for a year worth of data. So that doesn't help us, right? So in those cases also bucketing can be useful. And internally, how bucketing works is that a hash value is generated for every unique value in the column used for bucketing. The hash value generated for every record determines the bucket it belongs to. Okay, so this is very useful thing to understand, that how bucketing works underneath, and what is this hash value that I'm being like mentioning over and over, in order to segment the data into different buckets. So let me just try to paint a picture over here to make you understand that how it works. So suppose I have three buckets. Okay, so there is one table that I want to create three buckets on top of it. Just pardon my, okay, let me just make it as uniform as possible. So this is another bucket and this is another bucket. I know my painting is really not that good, just bear with me. I'm just trying to make you understand how it works. So suppose say this one, okay, yeah, so this one is the zeroth bucket, this one is bucket one, and this one is bucket two, right? So And now what I'm trying to do is that I want to put the ID column for my bucketing column, and I want and there is three buckets, right? So the fact of the matter is the ID column value for each and every column value. By the hash formula, it will be decided that onto which bucket the that particular column value will be shifting into. Okay, so suppose my ID columns is somewhat like 1, 2, 3, okay, 4, 5, 6, 7, and so on. Now I have three buckets, right? So the hashing formula is such that it is the column value uh, divided by the number of buckets. So over here it is 3, and the remainder is actually the bucket number. I mean, onto which bucket that particular column value will be going in. Okay, so over here, one is the column value, right? ID is my column, and the column value is 1, 2, 3, 4. So one is the column value for this one, and then it should be divided by 3. That is the number of buckets, and this gives me a reminder of 1, right? So this will go into this one bucket 1. Okay, and then if I come to the second column value, that is 2, and if I try to divide it by 3 and then take the remainder out of it. Remember, it's not actually the division result, it's the remainder that signifies the bucket number. So this gives me 2. So this ID column value 2 will get into the second bucket, or the bucket number 2. And for the third one, it is divided by 3, so obviously 3 is divisible by 3, so in that case the remainder will be 0, and this will go into the zeroth bucket. Right, similarly, now coming to this one, so this will be again divided by 3, and this will give me a remainder of 1. So this column value 4 will be now into the bucket 1. So now I have 1 and 4 both into bucket 1. All right, now coming to the next one. So this one is divided by 3, and my remainder is 2. For this one is divided by 3, and this again will give me 0. And for this one is 7 divided by 3, and this will be 1 again. So this will go into the first bucket. So just take a look at the bucket numbers and corresponding column values. So 1, 4, 7, these are all going into the bucket 1. Similarly, 2 and 5, so these are going into bucket 2, and 3 and 6 are going into bucket 0. So that's how the data has been segmented based upon the column value that is for the column ID, and this is how each and every data is chunked in, I mean segmented into different buckets, and that's how it is decided. So this is actually helps. So this is how bucketing is done, and it helps in chunking the data into different buckets, or different blocks of a Hive table. Right. So, this is actually how bucketing works. Whereas for partition, it was quite simple. I mean, whatever be the partition column value, into those all the same column values will go into. But in case of bucketing, this is how the hash value works. Okay, so this is the theory portion of Hive bucketing, how it works. Now let me just go into let me go into the Hive cluster, sorry, the Hadoop cluster, and check a detail overview of the Hive bucket table. So now I have just opened my terminal, and I will try to log into my Hadoop cluster. So I will just run or initiate all my Hadoop daemons, that is the name node, data node, everything that are required. Okay, so let me start all this. So you have to set up all these things into your local system. You can use a WSL. uh, Mostly preferred one is the WSL. You can run on EMR nodes. So if you want to know how to set up Hadoop clusters in WSL in local system, you can reach out to TechSpark, and we will obviously guide you. Okay, so yeah, all the Hadoop node manager, resource manager, yarn, everything is up and running. Now I will initiate my Hive cluster. Okay, to initiate the Hive cluster, first I have to start the Hive metastore. And the Hive metastore is the one which takes care of all the metadata information, the tables, the database, and everything that Hive requires. Now I will connect to the Hive server. So no need to, panic all the, no need to panic on all these things. I mean, whatever the command that I'm currently running. So these are just usual commands that I have to run every time I try to start the Hive console. And, we will guide you, we will guide on all of these things, how to create Hadoop cluster, how to create a Hive console and everything on your local system so you can get started with it. So for this one, okay. So my Hive server is up and running. Console is also now up. Uh, so I will use my database, that is Data Hub, and I will check the tables that are present. So currently I have these tables present over here. EV population is a normal table as in it's not partitioned or bucketed. EV population is the bucketed table. So currently this table is already created, but I'm going to show you how to create the table and how to insert the data from the normal table, that is EV population, and after then how it looks like. So let me just drop this table for the moment so I can create the table right in front of you, and you can see how the create table statement also looks like. All right, so my table is dropped. Now, first thing is that I have to create the Hive table, the bucket table. So to create the bucket table, I need the create table statement for my bucketed table. But before creating a bucket table, or before even try to create a table which needs to be bucketed, so there is one command that I need to run. So that is enforcing the bucketing. So this is just one single command, set Hive enforce bucketing equals to true. So after this, I'll be able to create the bucketed tables without any issue or anything. Okay, so let me copy this one. So this is my create table statement. The table is already created, and I'm just I know the schema of this table, the data EV population, right? So I have already defined the columns that should be part of the table. That is the county, city, model year, make, and then electric range, utility, and whatnot. So this is usual create table statement, right? Create external table, table name, and then the column names. Now, if you look at the second line, that is clustered by model year into three buckets. So this is the significant point that you need to look into. And this is actually signifying that my table will be bucketed. Okay. So the clustered by is the keyword that kind of indicates that my table will be bucketed. Now, if you remember when I was showing you the slide over here, so there is this cluster keyword that I mentioned over here, just to make sure that I'm talking about the bucketed table. So this is the reason that I put the clustered keyword there, so you can sync up with that. In the create table statement also, I'm using the clustered by command, and followed by the column name, for which I want the bucket. Sorry, by which I want my table to be bucketed, and then I have to hard code the number of buckets that I need. All right. So just have a look at this picture again, and try to sync up my create table statement. So over here, the column value for each and every ID, now this will change to model year, right? Because I don't have an ID column in my table, so instead I'm using model year. Now model year is also a year which is a numeric value, so obviously divided by a numeric, and then remainder is something that we can get. But what if the column name is a string, or suppose there is no numeric column present at all? So in that case, I have to consider a string column in order to bucket my table. So in but worry not, because even if I use a string column, so Hive internally, what it does, it just creates a number out of it, and then using the same hash formula, the ones that are having the similar remainder value will co-located into the same bucket. So it doesn't matter whether my column field is numeric or string, the hash value will work upon all. So it's kind of a generic thing. All right. So this is the statement. I'm hard coding the number of columns, and also I'm, putting the column value for which the hash formula should be worked upon. And then the last one is stored as parquet. So if you see over here, unlike the partition table, I am not putting any HDFS location over here. I'm not putting any location at all. The reason being because I have created a table, but the data that I'll be ingesting is from another table, even though that table is not bucketed. It's a normal table. But the thing is that I'm not creating the schema on top of a already present data in Hadoop. So that is why I'm not pointing to any Hadoop location over here. So my table has been created. Now all I have to do is just insert the data from that EV population table into this one. So this is my normal table, which is not bucketed. And let me run the insert statement over here. So it's pretty straightforward. Let me copy this one. Okay, so just have a look at the statement. It's pretty straightforward and self-explanatory. So insert override table EV population bucketed, the table that I just created. So insert override insert. Obviously, I'm inserting for the. So obviously, I'm trying to load the data for the first time. So insert and then override. Override means even if there is some data, that will be totally rewritten. But in my case, it's an empty table, right? So anyways, there won't be any data. And then I'm mentioning the select star from EV population. So whatever data inside the EV population, I want to load all the data into my EV population bucketed. So let me run this query, and you'll see in no time, yeah, the MapReduce job has commenced. So like as stated earlier, Hive by default runs the MapReduce job under the hood. So that's what's happening over here. It is done. So let me try to do a select star query, but let me first set the header over here, hive.cli dot. Right. Now let me try to do a select star. And I'm gonna put a limit over here. Yeah, so I have the data now loaded into my bucketed table, and it's the same data that is coming from the EV population. Okay, so now the bucketed table is created. So from this data or from the Hive, I'm not able to understand that how the chunks are created, right? When I said that there will be this column value will be going to that bucket, the other one will be going to a separate bucket. So where are these buckets created? Okay, I don't see any buckets. So to see that, actually the Hive will create files in the Hadoop file system, because at the end of the day the actual data will be residing into our Hadoop data lake, right? And Hive will simply store the metadata information. Okay, so to know what is the Hadoop location, let me just do a DSC formatted on the table name. Okay, so yeah, so this is my table name. Now, uh, remember, so if you notice one thing over here is that I have this location, HDFS location, but at the same time, I see that it is showing us external table. I mean, the HDFS location is pointing to a warehouse or a metastore directory, right? But still, I'm seeing an external table. Now, if you remember from the session, internal versus external table, is that for internal table, the data will always reside into the Hive metastore, that is this user Hive warehouse directory, and also the metadata information will also belong to the Hive metastore. Okay, but in case of here, what's happening is that I didn't mention any location at all while creating the table. If you remember that I mentioned that I'll be loading the data from another table, it's not on top of data that is already there in Hadoop. So that is the reason I didn't put any location, but I did put the keyword external table. So what's happening is that even if I drop the table, the data will be here inside this path, but the metadata information is gone. Okay, so that's the beauty of it. I mean, even though it is inside the Hive metastore, just using the external keyword, I have been able to make the data, kind of like fault tolerant, that even if I somehow drop the data, eventually the actual data will still be there. Okay, so this is one thing to highlight. The other one is the bucket information. Obviously, you'll see one more key information over here, that is the bucket columns model here. So this signifies that my table is now bucketed. To confirm that. Okay, so now from the table metadata perspective, I know that this bucketing is done. There's the bucket version, number of files, and all these things. Now let me take a look at the HDFS location, how it looks, and see like how many buckets or how many files are created. Okay, I have copied this path. Let me get out of the Hive console, Control Z, clear the screen, and then let me take you to the path where the table is created. Okay, right. So there are three files, right? Like, no surprise. I had mentioned three buckets while creating the table, and similarly, there are like three files over here. So each and every file signifies a single bucket over here. And what I was mentioning, or what I was showcasing while explaining how the hash value works. So for each and every particular column value, whatever be the hash, I mean, using the hash formula, whatever be the remainder value, those similar values have been co-located into same buckets. Now we don't know, I mean, which bucket holds what data, but uh, it's up to the Hive hash formula, is that the data is chunked into only these three files, and using that hash formula, the data has been redistributed. Okay, so this is the significance of the Hive bucketing, and this is how we basically chunk the data into n number of buckets. It's totally up to us. We can define the number of buckets, but also we have to make sure that we shouldn't have any skewed data. Skewed data, as in, suppose one of the bucket has a very large number of data while the other one has a very low number of data. In that case, that doesn't help us much in query optimization. So these are things that we must consider. I mean, same goes for partitioning as well. If there are any field value which we are thinking that should the table should be partitioned upon, but we see that it has a very high cardinality, in that case also partitioning doesn't work. So this features like partitioning or bucketing, that is like a gift to us to use, but we have to be very careful while using these features. I mean, that's where the utility of data engineers come in, is that they have to make sure and understand the data, that how to segment the data, or how to put the data into different blocks, so that the each and every block contains almost the similar amount of data. Okay, so this is all about Hive bucketing and regarding this session. So if you want to know more about Hive, Spark, or anything related to data engineering, just reach out to us, reach out to TechSpark, and we will help you, get to know about this, or this data engineering course that we have been talking about. We cover all the necessary tools in our course, such as the Spark, Hadoop, Hive, AWS, with hands-on coding as well as real-world project, and we will assist you in getting a job. We will make a interview-ready profile for you, so you can, easily crack all the interviews, and they will have some real-world questions. It's not going to be only theoretical ones. So we will cover everything regarding that. So see you on the next session, and for that moment, bye bye.
Contact us for the free job assistance. We will help you to get the IT job. Please like, subscribe, and share the channel for more regular updates from TechSpoke.